We're going to look a little bit at project organization. A project can be laid out in linear structure where all the commands are grouped one after the other and can be looked at in one scrolling file. Or you can use a modular structure where different blocks of code are in different places and they can be called multiple times. And the modular programming can help make a program more organized and more efficient. And there are three structures that we'll look at in this modular programming. One is an organizational block, or an OB. One is a function block, the FB, and finally a function, or FC. They all have similarities and differences. First, the organizational block, and this is a way of grouping code. For example, the main program is an organizational block. So whenever you're working with main in Siemens, that's an organizational block. And it's used to structure or organize a program. Now, it's not very flexible in that an organizational block is going to do the same thing whenever it's called. And this is different from a function block or a function, and we'll see those later. But an organizational block can be it can be called multiple times. And so that way, if you want to make a change, you only have to change it once, and it will change it everywhere that you call it. And it can also save from having lots of code because you can just call this organizational block multiple times. So it's good for organization. And it's possible just to have one organizational block. So if you could just have your entire program inside a main. And that would be an example of a linear program. There are different types of organizational blocks. Main is a program cycle OB, and here are some others. And here's an example of OBs being used. So when the PLC is turned on, a startup OB runs, and then we come into the program cycle OB. And while it's running, there could be interrupts that call interrupt OBs. So here's an example of organizational blocks being used. You just see that execution goes from one block to the other and then back to the calling block. Function blocks. So this is a function that's able to remember its last operation. It has memory. It can manipulate fields or memory that are specific to that instance of a function block. So you can have different function blocks that each have their own set of memory. And it's a subroutine that's executed when it's called from another code block. So either an OB, FB, or an FC. FC we'll get to in a second, that's function. And the calling block can pass parameters, which are called inputs, and also get values, which would be outputs from the FB. And the calling block identifies a specific data block for the FB to use. So that DB is where the function block stores its instance memory. And we'll look at this in a couple of examples in a minute. Hopefully it'll become clearer. The FB has different types of tags in it. So it has input and output, and input can only be read inside the FB. Output can only be written to. So when in the FB, the output can only be written to, and in-out can either be read or written to. There are also temp and static and other types of tags. Temp and static are just internal memory or internal variables that are used by the FB, and static ones can be accessed from other calling blocks. And again, the data block is associated with the FB when an instance is made in the calling block. Here's an example of a custom FB function block, and we've made one that operates a valve. So this has, say, code to open or close a valve depending on certain circumstances. And then in our program, we might make different instances of this FB or function block. And each of those instances is going to have its own data block. And so this data block is used for valve 1. So this keeps track of memory associated with valve 1, so input and output memory, for example. and then this data block is used for valve 2, and this one's for valve 3. So you can see here how function blocks are sort of organized. You have code that's generic, but then memory that makes each instance specific to a certain facet of the project. So we have the generic code and then memory that makes it specific for valve 1, memory for valve 2, memory for valve 3 in this example. A few more examples. Here is the ladder logic program for a different FB, and in this program we're using system functions, norm, scale, and system functions are either FCs or FBs, so function blocks, for example, that are in libraries available for you to use that Siemens wrote. So an example of a system function would be a TON function, or the timer delay on function. Anyway, in this FB we're using some system functions, and we have these tags: analog, count, norm val, scale val, RPM, and low alarm and high alarm. And we're performing some logic and operations with those tags. And this is what the function block program looks like. Now let's see what the function block looks like whenever we call it. So here is the input conversion block. We just looked at the code for it, and here's what it looks like in the calling block whenever we call that function. And here's what it looks like in the project organization tree. So here we have main, and then here's our FB input conversion when we use that, and then here's the associated data block to go with it. Whenever you're modifying the FB, you can look at the tags for it, or add tags, etc. So we have these input tags and output tags. And in this case, we didn't have any in-out tags or static tags. So here is a program that is using the input conversion function block, and we're using it twice. Here you have the enable line, and this is what makes the function block run. If this is true, then the function block is going to be running. And so if this is true, then this one is going to be true. So both these function blocks are going to be running in this example. They'll be running all the time because this is always true. And you can see that each one has its own data block. So this instance of the FB has DB1, and this instance has DB2. And so that means that this one has its own memory that's different from this one. And in this example, the memory here is associated with motor 1. So we have the analog count for motor 1, and then we have some memory for the RPM for motor 1, a low alarm, a high alarm for motor 1. And then the next instance of that function block, its memory is associated with motor 2. So you can see that we can save space and make things more efficient and also easier to manage by using function blocks, because we have one set of code that monitors a motor, and then we just use different data blocks to work with values that are specific to different motors. You can add FBs to your project library so that it'll be in your library. And the same is true for FCs. FC is a lot like an FB. It's a subroutine that's called from another function block. So again, it can be called from an OB, an FB, or another FC. The FC, or function, typically performs a specific operation on a set of input values, and it stores the results of this operation in memory locations. And they're typically used to perform the following types of tasks, like standard and reusable operations, such as calculations, and individual controls using bit logic operations. So the difference between FCs and FBs is that an FC does not have an associated instance database. So you can call an FC multiple times or at different places in a program, but every time you do, it's going to be modifying the same memory. So that's different from an FB, because with an FB, or a function block, whenever you call it, it can have, every time you call it, it can have a different set of memory. So an FC is more customizable than an organizational block because you can pass it different values to operate on, so it can come up with different results when it's run, unlike an organizational block, which is just going to do the same thing every time. But an FC is not as flexible as an FB because you can't have different instances of it, or you can't have memory specific to each instance for an FC. So here's an example of an FC. This is the code inside a calc weight function that we created. And again, this is using a couple of system functions, normx and scalex. And we're taking this tag, load sends, and the output of that norm is assigned to weight norm tag, which is the input to the scale function, and that outputs this weight to the weight tag. In our FC, we see that we have those three tags. Load sends is an input to our function, WGT is an output from the function, and weight norm is a temp tag, so that's just memory that's used internally in our FC. And this is what it would look like from the calling block. So here is calc weight FC, and you can see that it has one input, which is load sends, and one output, which is weight. And if you look back at the tag, here's the input tag and the output tag. And in the project tree, you can see that there is it shows that we're using this calc weight FC, but there's no associated DB because it's an FC and not an FB. And similar to function blocks, you can add FCs to your project library.